Greetings, my cosmic explorers. I'm Tobol, your guide to the mysteries of the universe. Welcome back to my blog, where science meets attitude and wonder knows no bounds. Today, we dive into a radical physics model that dares to ask, what if time has 3 dimensions, and space is just its shadow? A radical new physics model suggests our universe might be built on 3 dimensions of time, not just space. This isn't sci-fi. It predicts real particle masses, hints at why gravity and quantum physics won't talk, and turns reality inside out. Space might emerge from time. Could this be the key to a theory of everything, or wild speculation? You decide. To help us unravel this dramatic story of our celestial guardians, I've brought along the brilliant Brian. So grab your coffee, fasten your seatbelts, and get ready for some serious celestial wisdom. Brian, the floor is yours.
Thanks, May. You always set the stage beautifully. Now let's explore how these challenging circumstances will transform our awareness and what they mean for the advancement of human understanding. Imagine waking up tomorrow and realizing that everything you thought you knew about time, that steady one-way river flowing from past to future, was only a sliver of a much grander, stranger reality. What if time isn't a line, but a volume? What if, just like space has height, width, and depth, time has 3 dimensions too? This isn't science fiction. This is a serious, albeit radical, proposition emerging from the frontiers of theoretical physics. A model, quietly published and passionately debated, dares to suggest, what if our universe isn't 4D, 3 space plus 1 time, but 6D, 3 space plus 3 time? And here's the twist. In this model, time doesn't happen within space. Space happens within time. Welcome to the theory that turns reality inside out. The canvas before the painting. For over a century, Einstein's space-time has been the bedrock of modern physics. 3 spatial dimensions, 1 temporal dimension. Together, they form the stage upon which all matter, energy, and forces perform. It's elegant, it's predictive, it's been confirmed by countless experiments, from GPS satellites to gravitational wave detectors, but it's not complete. Gravity refuses to shake hands with quantum mechanics. The standard model can't explain why particles have the masses they do. Neutrinos ghost through our detectors with unknown heft, and despite decades of effort, the theory of everything remains stubbornly out of reach. Enter Dr. Gunther Quitke. Yes, the physicist hugging a cactus in his author photo, from the University of Alaska. His proposition is disarmingly simple. If space has 3 dimensions, why shouldn't time? Not as a mathematical trick, not as abstract algebra, but as physical, real dimensions, woven into the fabric of existence, shaping the behavior of particles, forces, and perhaps even the birth of space itself. In Quitke's model, time isn't a single arrow, it's a triad. The first dimension, the familiar arrow, past to future, causality, entropy, the time of clocks and calendars. The second dimension, the quantum fork, branching possibilities, parallel outcomes, the what-if axis. Think Schrödinger's cat, alive and dead, but now spatially separated in time's second direction. The third dimension, the bridge between timelines, the dimension of transition, of probability flow, of cosmic phase shifts, the axis that lets one quantum branch evolve into another. Picture it like this: you're not just moving forward in time, you're also moving sideways into alternate versions of now, and upward/downward between those realities. Time becomes a landscape, a topography, a 3D grid where every event isn't a point but a volume. And here's where it gets wild. Space in this model is not fundamental, it emerges. Like ripples on a pond, the 3 dimensions of space arise from the structure of 3-dimensional time. Time doesn't unfold in space. Space unfolds from time. The canvas comes first. The painting, our 3D world, is what appears on it. Predictions that defy coincidence. What makes this more than philosophical daydreaming? It predicts things. Quitke's equations, derived from the geometry of 3D time, spit out numbers. Specific, measurable, testable numbers. The mass of the top quark, predicted 173.21 GeV. Measured 173.2 GeV. The ratio between electron, muon, and tau lepton masses, predicted 1 4.521 observed shockingly close, the mass of the neutrino, still unknown to experimental physics. The model gives a precise value, and a structure of resonances depending on neutrino type. These aren't tweaks. These are outputs, derived not from fitting data but from the intrinsic structure of a 3D temporal geometry. Even more tantalizing, the model predicts that gravitational waves travel slightly slower than light, a difference so tiny it's only detectable across billions of light years. Future observatories might catch it or rule it out. This is the razor's edge of science, a theory that doesn't just explain, it dares you to test it. The ghosts in the machine, and the critics who haunt them. Of course, radical ideas attract radical skepticism. Max Tegmark, famed for his mathematical universe hypothesis, has long argued that multiple time dimensions spell chaos. Why? Because cause and effect break down. Particles become unstable, protons decay, electrons vanish. In such a universe, complexity, let alone life, may be impossible, unless the energy is near absolute zero. Others dismiss multidimensional time as unfalsifiable metaphysics, beautiful math with no tether to reality. After all, if you can't build an experiment, is it even science? And then there's Occam's razor. Why add dimensions when 4 work so well? Our current model explains galaxies, black holes, atomic spectra, and the cosmic microwave background. Do we need more? Kwiatko's answer? Maybe not, until we hit the walls, until we face the questions 4D space-time can't answer. Like why the Higgs boson weighs what it does, or how gravity whispers to quarks. His model doesn't claim to be right, it claims to be fruitful. A new lens, a different coordinate system for the cosmos, and sometimes that's how revolutions begin. Not with a bang, but with a shift in perspective. String theory's cousin, and why this one might be different. You've heard of string theory, with its 10, 11, or even 12 dimensions. Some versions, like F-theory, even include 2 time dimensions, but string theory remains untested, elegant. Yes, verified, not yet. Then there's Isaac Barr's 2-time physics, another valiant attempt to unify forces through extra-temporal dimensions. Again, mathematically rich, experimentally silent. What sets Kwiatko's 3D time apart? Testable mass predictions. Not just this could explain gravity, not just this fits quantum weirdness, but here is the mass of the neutrino. Go measure it. Prove me wrong. That's the gauntlet thrown. What if you lived in 3D time? Let's play. If time has volume, what does now mean? Is your present moment just one slice in a vast temporal block? Are alternate versions of you? Who took that job? Who didn't say goodbye? Who turned left instead of right? Not elsewhere in space, but elsewhere in time's second dimension. Could meditation, déjà vu, or quantum observation be glimpses into time's lateral axis? Could the arrow of time be just one vector in a 3D temporal wind? And if space emerges from time, does that mean the Big Bang wasn't the beginning of space-time, but the crystallization of time-space? These aren't answers, they're provocations. The model doesn't demand you believe, it invites you to imagine. The path forward, and why it matters. Science doesn't progress by clinging to comfort, it advances by questioning the unquestionable. 3-dimensional time may be wrong, it may be untestable. It may collapse under mathematical scrutiny or experimental contradiction, but it may also be the key that unlocks quantum gravity, the missing symmetry that explains mass hierarchies, the reason neutrinos are so light, the bridge between the quantum foam and the cosmic web. And even if it fails, it will have done its job by forcing us to ask, what if time is more than we think? Future particle colliders, next-gen gravitational wave detectors, precision neutrino experiments, they hold the verdict. Until then, the theory stands not as truth, but as possibility. Your turn. So, what do you think? Is time a river or an ocean? Is our 3D world the stage or the shadow? Could the secret to unifying physics lie not in more spatial dimension, but in deeper temporal ones? Don't answer with certainty, answer with curiosity. Sketch your own model, question the arrows, redraw the axes, because the universe doesn't care what we believe, it only reveals itself to those who dare to ask. What if?
And there you have it, my lovers of the labyrinth. Remember, every challenge is just a stepping stone to greatness. If you enjoyed this episode, don't forget to hit that like button, subscribe so we can keep exploring together, and drop a comment to share your thoughts. Until next time, stay curious, stay bold, and keep chasing those dreams.